From the first moment human beings lifted their eyes toward the night sky, the question has been waiting for us. What is the connection between the mind that looks and the universe it beholds? Every culture has asked it in its own language. Some saw divine breath in the heavens, others spoke of hidden mathematics. Yet beneath the myths and the formulas lies a single intuition, that awareness and cosmos are somehow entwined. The mystery of the mind and the universe is not new, but our tools for exploring it have changed. We no longer look only through temple doors or mystic visions. We look through telescopes, microscopes, and the mathematics of modern physics. And still, the feeling remains. When we study the universe, it feels as though something within us is studying itself. The story begins with the birth of everything. 13.8 billion years ago, all that would become galaxies, stars, planets, and people existed as a point of energy beyond imagination. In an instant, space itself began to expand, carrying with it the raw ingredients of existence. In that expansion lay the potential for everything, including thought. Matter cooled, atoms formed, stars ignited. In those stars, heavier elements were born: carbon, nitrogen, oxygen, iron. When those stars died, they scattered their ashes into space. From those ashes, new stars formed, and around them, planets. One of those planets had oceans, air, and the perfect balance for life. Somewhere within its chemistry, the first cells stirred. Those simple cells multiplied, evolved, and after billions of years became creatures capable of reflection. Every time a human wonders about the universe's own matter is wondering about itself. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of every cell, all were once inside the heart of a star. To grasp that fact is to see the first thread between the mind and the cosmos. We are not outside observers. We are participants woven from the same fabric we study. The laws that guide the fall of comets also guide the firing of neurons. Gravity binds the stars together. Electromagnetic forces bind your memories into coherent patterns of thought. The human brain is a masterpiece of organization. 86 billion neurons, each connected to thousands of others, form a network so intricate that its possible connections outnumber the stars in the observable universe. Every thought you have, every image, word, or feeling, is the coordinated dance of electrical impulses across that network. Yet what emerges from this dance is something science still cannot fully describe: consciousness. We can measure brain activity, map regions responsible for sight or speech, even predict decisions a fraction of a second before they reach awareness. But none of this explains what awareness is. What does it mean that you experience the color red, or the sound of rain, or the thought of your own existence? This hard problem of consciousness has puzzled philosophers for centuries. Some argue that mind arises purely from complex computation, that consciousness is an emergent property of information processing. Others suspect that something deeper is at play, something that cannot be captured by equations alone. When we turn to the foundations of physics, the mystery deepens. Quantum theory, our best description of the microscopic world, tells us that particles can exist in multiple states until observed. The simple act of measurement appears to crystallize potential into reality. Whether or not consciousness itself performs that role is debated fiercely, but the parallel is tantalizing. Awareness seems to bring order to the chaos of possibility, just as observation does in the quantum world. At first glance, the quantum realm and the human mind could not be more different, one ruled by probability, the other by perception. But both share a peculiar trait. They reveal that reality is not as solid or straightforward as it appears. Beneath certainty lies uncertainty, and within uncertainty lies the seed of awareness. To understand this connection, we must first grasp what the brain truly is. Inside its protective skull, the brain is a moist lattice of cells bathed in electrical and chemical exchange. Every second, trillions of signals traverse its networks, encoding the sensations of the moment, the memories of the past, and the predictions of the future. But the thing doing the encoding is made of atoms, the same atoms that obey quantum laws. Some researchers have proposed that consciousness might emerge from quantum processes within neurons themselves. Others reject that idea, pointing out that the brain is too warm, too noisy for delicate quantum states to survive. Whether true or not, the proposal touches on something profound. If mind and matter are part of one continuous reality, then perhaps the line between them is an illusion of scale. When we zoom out, we see the cosmos expanding through time. When we zoom in, we find the dance of particles within every thought. Between those extremes lies a pattern, the rhythm of complexity arising from simplicity, of order blooming from energy. Across millions of years, evolution sculpted the brain not only to survive but to ask questions. Awareness became a tool for prediction, empathy, creativity. In that sense, consciousness is the universe's strategy for knowing itself more deeply. A galaxy can burn for billions of years, but it cannot think about burning. Through us, the cosmos gains reflection. Even our emotions, often dismissed as chemical storms, have their cosmic lineage. Joy, fear, curiosity, these are expressions of the same physical laws that drive stars to fuse hydrogen or galaxies to spiral. They are the subjective side of universal processes. The universe expands outward in space. The mind expands inward through thought. Consider the image of a neuron firing. A burst of electricity travels down its length, releasing molecules across a tiny gap to the next cell. That pattern spreads, forming waves of activity across the brain. In those waves lie everything we experience. Now consider a star shining, nuclear fusion releasing photons that travel through space for millions of years. Both the neuron and the star transform energy into light, one within the skull, one across the heavens. These analogies are more than poetic. They remind us that the distinction between inner and outer, micro and macro, may be one of perspective only. Physics describes relationships of energy and information. Neuroscience describes them at a particular scale. Awareness is what it feels like from the inside. Our ancestors sensed this connection intuitively. They mapped constellations not only on the sky but within themselves. Myths of sun gods, moon deities, and cosmic serpents mirrored the cycles of the human psyche. Today, we frame the same intuition in equations and data, yet the wonder remains unchanged. The night sky still invites the same silent question. Why does there exist something that can see it? Modern science, despite its precision, has not erased that question. It has, if anything, made it more mysterious. The more we learn about the cosmos, its vast age, its fine-tuned constants, its delicate balance that allows life, the more extraordinary it seems that awareness could emerge at all. The odds appear astronomically small, and yet here we are, thinking, questioning, feeling. Perhaps consciousness is not a rare accident but an inevitable outcome of complexity, a principle written into the laws of nature themselves. Just as gravity draws matter together, maybe consciousness draws information into meaning. When matter reaches a certain threshold of organization, the spark of awareness ignites, and the universe gains a new way of perceiving itself. The mystery, then, is not only how the brain produces mind, but why the universe allows mind to exist at all. Out of the cold void and silent equations came warmth, color, emotion, story. The atoms that once drifted through space now compose poems, symphonies, and dreams. The mind and the cosmos mirror each other, one vast and external, the other intimate and internal. Both are expanding. Both are filled with light and darkness. Both contain mysteries that may never be fully solved, yet both are parts of a single reality unfolding through time. If we listen closely, we might sense that every thought, every breath, is an echo of that unfolding, the universe contemplating itself through the fragile vessel of the human brain. The nature of consciousness is the quiet miracle that makes every fact about the universe meaningful. Without it, there would be no experience of the stars, no awareness of beauty, no curiosity to ask why things exist at all. Yet despite being the most immediate part of reality, it is also the hardest to define scientifically. In biology, consciousness is usually described as the state of being aware of internal and external stimuli. But awareness itself, what it is made of, how it arises from matter, remains an open question. When neuroscientists record electrical activity from a brain, they can measure patterns of energy, not the subjective feeling that accompanies them. Somewhere between firing neurons and lived experience, an invisible transition occurs. The modern study of consciousness began in earnest during the 20th century, when technology finally allowed scientists to peer inside the living brain. Electroencephalography revealed the rhythms of neural oscillations, alpha, beta, delta waves, that correspond to wakefulness, sleep, and attention. Later, functional MRI made it possible to see which regions of the brain become active when we see, speak, or imagine. These discoveries built the foundation for what is called the neural correlates of consciousness, the physical patterns consistently associated with conscious experience. Yet identifying correlation is not the same as explaining causation. We know that activity in the visual cortex accompanies sight, but we still do not know why that activity feels like seeing light and color instead of remaining an unconscious computation. To grasp the challenge, imagine a robot equipped with the most advanced sensors. It can register temperature, light, motion, and sound more accurately than any human. But does it feel anything? Does it have an inner world? If not, what ingredient is missing? The difference between information processing and conscious experience defines the frontier between artificial intelligence and living awareness. Several major theories attempt to cross that frontier. One of the leading frameworks is integrated information theory, IIT, proposed by neuroscientist Giulio Tononi. It suggests that consciousness corresponds to the amount of information integrated across a system. A highly connected network where every part influences the rest cannot be reduced to separate components. It forms a unified whole. According to IIT, that unity is consciousness. Another influential model is the global workspace theory, advanced by Bernard Bars and expanded by Stanislas Dehaene. It likens the brain to a theater. Many unconscious processes work behind the scenes, but only information that enters the global workspace, the brightly lit stage, becomes conscious. Neuronal networks broadcast that information to the rest of the brain, allowing decision, language, and memory to coordinate. Consciousness, in this view, is the broadcasting function itself. These models differ in language but share a key insight. Awareness emerges from complex communication among neural systems. The more information flows and integrates, the richer the experience. When those connections are disrupted by sleep, anesthesia, or injury, consciousness fades or fragments. Still, even if these theories map how awareness behaves, they leave open the question of why it exists. Why should any arrangement of matter produce a first-person perspective? Philosophers call this the hard problem, a term introduced by David Chalmers. It stands apart from the easy problems of explaining memory, behavior, or perception, tasks that can be described mechanistically. The hard problem asks why any of those processes are accompanied by experience at all. Some thinkers argue that consciousness might be a fundamental feature of reality, not something derived from physical interactions. This position, known as panpsychism, suggests that every component of nature has at least a minimal capacity for experience. In that sense, the universe is not built from dead matter but from proto-experiential elements that, when organized into brains, yield the vivid consciousness we know. While controversial, the idea forces science to reconsider the assumption that mind appears only at certain levels of complexity. From a neuroscientific perspective, however, consciousness has practical markers. It depends on metabolism. A brain starved of oxygen loses awareness within seconds. It depends on connectivity. When the thalamus or cortex is damaged, consciousness can vanish even though reflexes remain. It depends on time. Conscious perception integrates signals over about a quarter of a second, stitching discrete events into a continuous flow. These observations anchor consciousness firmly in biology. Yet the biology itself is bound by physics. The ions that charge across neuron membranes obey the same quantum rules that govern atoms everywhere. Awareness, therefore, cannot be separated from the physical universe. It is an emergent property of its laws expressed through living matter. When scientists model brain activity, they often use the language of networks. Each neuron behaves like a node exchanging information with thousands of others. What matters most is not the individual neuron but the pattern of connectivity, the topology of the network. Certain patterns yield stable states of self-reference, loops that process information about their own state. In principle, such self-referential systems could generate the subjective point of view we call the self. This brings us to another central aspect of consciousness: self-awareness. To be conscious is one thing, to know that one is conscious is another. Many animals demonstrate perception and emotion, but only a few appear to recognize themselves in a mirror. Humans take self-awareness further still, constructing identities, narratives, and beliefs about the past and future. Cognitive scientists trace self-awareness to the brain's capacity for metacognition, the ability to think about thoughts. When neural networks in the prefrontal cortex and parietal regions interact, the brain can represent its own internal states. It can notice attention, evaluate confidence, and imagine alternative possibilities. Through that mechanism, the universe develops a model of itself from within. Despite the progress of neuroscience, consciousness research remains one of the youngest branches of science. Tools like magnetoencephalography and high-resolution imaging are only beginning to capture the millisecond-level dynamics of brain activity. Computer simulations of cortical columns now attempt to recreate small pieces of conscious processing, bridging biology and computation. At the same time, quantum physicists and philosophers continue to ask whether consciousness might play a role at the deepest levels of reality. Theories such as orchestrated objective reduction, proposed by Roger Penrose and Stuart Hameroff, suggest that quantum effects in microtubules inside neurons could contribute to conscious awareness. The hypothesis remains speculative and contested, but it underscores the effort to unite physics and mind into a single coherent framework. In the broader scientific community, the consensus remains pragmatic. Consciousness arises from the coordinated activity of vast neural populations, but acknowledging that does not diminish its wonder. Every conscious moment is a triumph of organization, billions of cells exchanging electrical impulses to produce the fragile continuity we call experience. Awareness allows the universe to witness itself with precision, to analyze its own laws through mathematics and language. Through consciousness, the cosmos gains curiosity. It asks questions about its origin, contemplates its end, and invents instruments to peer back in time toward the Big Bang. In that sense, consciousness is not an accident within the universe. It is one of its ways of evolving knowledge. Even sleep, often thought of as unconsciousness, demonstrates the spectrum of awareness. During REM stages, the brain generates dreams, virtual realities created from memory and imagination. The same neural circuits used for waking perception reassemble into simulations of worlds that do not exist outside the skull. This ability to model alternate realities may have driven creativity, planning, and science itself. As neuroscience advances, the boundaries between consciousness and computation blur. Artificial intelligence now performs tasks once considered uniquely human, recognizing faces, composing music, generating language. Yet despite this progress, there is no evidence that such systems feel anything. They manipulate symbols. They do not have a point of view. The gap between simulation and sensation remains the defining line between machine and mind. Understanding consciousness scientifically does not diminish its mystery. It expands it. Each discovery reveals how finely tuned the brain must be to sustain awareness, how delicate the conditions that keep the light of experience burning. Somewhere within the exchange of ions and neurotransmitters, within oscillations and synchrony, matter becomes mind. The study of consciousness therefore stands at the intersection of disciplines: neuroscience, psychology, physics, philosophy, and even information theory. It invites collaboration between data and introspection, measurement and meaning. To explore it fully is to acknowledge both the rigor of science and the depth of subjective life. The universe, governed by impersonal laws, has produced entities capable of empathy, imagination, and moral choice. That transformation, from energy to awareness, may be the most remarkable evolution of all. In every human brain, 13 billion years of cosmic history culminate in a single question. What am I, and how do I know that I am? As we move forward in this series, we will trace how those questions lead directly into the fabric of physics itself, how the mechanisms that govern matter might also set the stage for mind, and how the observer participates in shaping the very reality observed. Hour 3, Quantum Physics, a window into reality. For centuries, science has sought to explain the workings of the universe, to reveal what matter is made of, how it moves, and what forces shape it. Classical physics, born from Newton's observations, painted a picture of a predictable world, a universe of solid particles obeying mechanical laws, where causes led to effects in a clear, deterministic chain. But as we peered deeper into the atom, that picture began to dissolve. The predictable world gave way to one built on uncertainty, probability, and paradox. What emerged was quantum physics, the most accurate yet most mysterious theory ever devised. It describes the world not as a set of fixed objects, but as a vast, dynamic field of possibilities, a universe woven from invisible probabilities waiting to become real. Quantum physics began humbly, with light. In the early 20th century, Max Planck discovered that light's energy could only be emitted in discrete packets, quanta. This strange idea was the first crack in the classical foundation. Then came Einstein, who explained the photoelectric effect. Light could behave as both a wave and a particle, depending on how it was observed. That duality, light as both continuous and discrete, both spread and localized, would become the hallmark of the quantum world. Soon, the same duality was discovered in matter itself. Electrons, once thought to be tiny solid balls orbiting the nucleus, could behave like waves. In the double-slit experiment, when electrons were fired through two slits onto a screen, they formed an interference pattern, the signature of waves overlapping. But when scientists tried to measure which slit each electron passed through, the pattern vanished. The electrons behaved like particles again. This was not a trick of the instruments. It was nature itself responding to observation. The act of measurement changed the outcome. The electron seemed to exist in a state of potential, a superposition of possibilities, until the moment it was observed. Then, from the haze of probabilities, a single reality emerged. At that moment, science faced a revelation. The universe is not simply out there, unfolding independently of us. The observer and the observed are deeply entangled. Reality, at its most fundamental level, is not definite until interaction, or observation, occurs. The mathematics of this strange behavior is governed by the wave function, a probabilistic equation first described by Erwin Schrödinger. The wave function doesn't tell us where a particle is, but where it might be. It encodes all possible outcomes, all potential states, coexisting until something, a measurement, an interaction, an observation, forces the wave function to collapse into a single result. What does that mean? In the quantum world, certainty gives way to probability. Electrons don't orbit like planets. They exist as clouds of potential locations. Photons don't travel in straight lines. They interfere with themselves across space. At the smallest scales, the universe behaves not like a machine, but like a sea of vibrating possibilities, a cosmic symphony where every note is a probability wave. Physicist Niels Bohr, one of quantum theory's founders, once said, "Anyone who is not shocked by quantum theory has not understood it." And he was right. Quantum physics defies human intuition because we evolved in a world of macroscopic objects, where things seem solid and predictable. But beneath that familiar surface lies a reality that is fundamentally probabilistic, non-local, and deeply interconnected. Heisenberg's uncertainty principle revealed that the more precisely we measure a particle's position, the less precisely we can know its momentum, and vice versa. This is not a limitation of technology, it is a feature of nature itself. The universe refuses to reveal all its properties at once. In other words, reality is inherently uncertain. As quantum theory evolved, It brought not only confusion but also power. It gave rise to modern electronics, lasers, semiconductors, and the computer revolution. Every time you send a message, store a file, or look at your phone screen, you are using devices powered by quantum mechanics. The same mysterious rules that blur the line between wave and particle also allow the digital world to exist, but deeper questions remain. If particles can exist in superpositions, being in multiple states at once, what happens to that superposition when we measure it? Why does the wave function collapse into one outcome instead of another? One explanation, known as the Copenhagen interpretation, proposed that quantum systems remain in superposition until they are observed, and that observation itself causes reality to crystallize into a definite state. This interpretation gave rise to one of the most famous thought experiments in science, Schrödinger's cat. Imagine a cat sealed in a box with a radioactive atom, a detector, and a vial of poison. The atom has a 50% chance of decaying, which would trigger the poison and kill the cat. Until the box is opened, the atom exists in both decayed and undecayed states. And so, according to quantum theory, the cat is both alive and dead at the same time. Only when the box is opened, when an observer looks inside, does the cat's fate become definite. The idea is not about cats but about reality itself. Before observation, the universe exists as overlapping possibilities. The act of observation appears to select one, as if consciousness plays a role in shaping what becomes real. Some physicists, like Hugh Everett, rejected the idea of collapse entirely. He proposed the many worlds interpretation, that every possible outcome actually occurs but in separate branching universes. When the cat's box is opened, there isn't one result, there are two universes. In one, the cat lives, in another, it dies. Every quantum event in this view splits reality into countless parallel worlds. Whether this picture is literal or metaphorical, it forces us to reconsider what reality means. Perhaps our universe is not a single, fixed line of events, but a vast, branching tree of possibilities, all existing simultaneously. Quantum physics also introduced the idea of entanglement, a phenomenon so strange that Einstein called it spooky action at a distance. When two particles interact and become entangled, their properties remain correlated, no matter how far apart they are. Measure the spin of one, and the other instantly reflects the complementary value, even if it's on the other side of the galaxy. This instantaneous connection appears to violate the speed of light limit. Yet countless experiments have confirmed that entanglement is real. The information shared between entangled particles seems to transcend space itself, hinting that the universe might be more deeply unified than classical physics allows. What's even more intriguing is that entanglement might be the foundation of spacetime itself. Some modern physicists propose that the geometry of the universe, the fabric of space and time, arises from networks of quantum entanglement. If true, then reality as we experience it could be an emergent phenomenon born from the invisible relationships between quantum bits of information. At this level, particles are not tiny balls of matter but excitations in quantum fields, ripples in an ocean of potential. Every particle is a vibration, every interaction a resonance. The universe, at its core, behaves more like a song than a machine. This insight brings science closer to an ancient truth echoed across civilizations, that everything is interconnected, vibrating, and dynamic. The quantum field is not empty. It teems with virtual particles appearing and disappearing in a restless dance. Even the vacuum is alive with energy. Physicists call this the quantum vacuum, and it may be the most energetic entity in existence. Within it lies the zero-point field, a sea of energy that persists even when all matter and radiation are removed. Some theories suggest that this energy could explain the mysterious force of dark energy, which drives the expansion of the universe. Quantum mechanics challenges every assumption about what is real. It tells us that solidity is an illusion. Atoms are mostly empty space, held together by invisible fields. It tells us that causality is not absolute. Events can be connected in ways that defy temporal order. And it tells us that the observer cannot be separated from the observed, that consciousness itself might play a fundamental role in defining what we call the world. Laboratories today, scientists use quantum principles to build technologies that border on science fiction. Quantum computers harness superposition and entanglement to perform calculations that would take classical computers billions of years. Quantum teleportation allows the transfer of information across space without physical contact. Quantum communication promises unbreakable encryption, secured by the laws of physics themselves. The more we apply quantum mechanics, the clearer it becomes that we are only scratching the surface of a deeper truth, a truth that merges physics, information, and perhaps consciousness itself. Quantum physics is not merely a theory of the small, it is a window into the underlying structure of reality. It suggests that the universe is not built from things, but from relationships, not from objects, but from information. Every atom, every photon, every moment of existence arises from an invisible web of probabilities, collapsing into reality through interaction. As we move further into this journey, we begin to realize that the boundary between mind and matter may not be as rigid as we once believed. If observation plays a role in the formation of reality, then the mind itself may be part of the equation, a participant in the cosmic process, not a passive spectator. The quantum world, then, is not distant from us. It is the foundation of our very being, the invisible architecture beneath every thought, every sensation, every breath. And so, as we gaze deeper into the subatomic realm, we are not just studying the building blocks of matter. We are peering into the source code of existence itself, the quantum field that dreams the universe into being. Entanglement and the cosmic connection. When Einstein first heard about quantum entanglement, he frowned and called it spooky action at a distance. He could not accept that two particles, separated by light years, might somehow share a single state. Yet experiment after experiment would confirm what the mathematics insisted. The universe is more connected than our common sense allows. Entanglement is one of the most mysterious phenomena in physics. When two particles interact in a certain way, they become linked, so profoundly that the state of one instantly determines the state of the other, no matter how far apart they are. Measure one particle's spin as up, and its partner will always be down. Separate them by meters, kilometers, or across galaxies. The correlation remains perfect. This isn't a signal traveling through space. No message races between them. Instead, it's as though both particles are expressions of a single, non-local entity that transcends distance. In quantum language, they share the same wave function. They are two ends of the same invisible thread woven through the fabric of reality. To grasp how strange this is, imagine flipping a coin here on Earth while another coin, entangled with it, sits on Mars. When you check yours and see heads, the one on Mars instantly becomes tails. The outcome isn't determined until measurement, yet the results are coordinated faster than any light-speed communication could explain. Einstein argued that there must be hidden variables, unknown factors determining the outcome beforehand. But in the 1960s, physicist John Bell devised a test to expose whether those hidden variables existed. Decades of experiments, using photons, electrons, even atoms, showed that Bell's inequality was violated. In other words, nature really does behave in a non-local way. Entanglement isn't a rare curiosity, it's a fundamental feature of the quantum world. Every interaction, every exchange of energy, every chemical bond creates subtle correlations between particles. The more scientists study it, the clearer it becomes. The universe is a network of relationships, not a collection of isolated objects. Modern technology now harnesses this eerie connection. Quantum computers use entangled qubits to perform parallel calculations that classical machines could never manage. Quantum communication systems use entangled photons to create encryption that cannot be hacked without breaking the laws of physics. These advances show that entanglement isn't just philosophical, it's practical, tangible, and real. Yet beyond the technology lies a deeper question. If matter can be entangled, could information, and perhaps consciousness itself, also share in this cosmic linkage. In the brain, billions of neurons fire in complex, synchronized patterns. Some physicists and neuroscientists have speculated that microscopic quantum processes, perhaps involving entanglement among subatomic particles in neural microtubules, might contribute to the unified experience we call awareness. The Orchard theory by Roger Penrose and Stuart Hameroff suggests that consciousness could emerge from quantum coherence inside the brain, momentarily linking regions of neural activity through the same principles that bind entangled particles. While still controversial, such ideas remind us that the mind may not be entirely classical. After all, the molecules composing the brain obey quantum laws. If entanglement helps maintain order among those molecules, perhaps it also plays a role in synchronizing the mind's inner world. Entanglement also challenges how we think about separation. In everyday life, we divide the world into me and not me, observer and observed. But quantum physics hints that this boundary is porous. Every measurement entangles observer and system. Every interaction is a handshake through the quantum field. The more we observe, the more entangled we become with what we observe. In 2017, a group of Chinese physicists used satellites to entangle photons across more than 1,200 kilometers of empty space, proving that quantum correlation persists on planetary scales. The result implied something profound. The laws that knit subatomic particles together operate across the heavens. The universe is a single quantum fabric whose threads stretch from the smallest electron to the largest galaxy. This perspective is beginning to reshape cosmology. Some researchers propose that space itself arises from webs of entanglement, that the geometry of spacetime is the macroscopic shadow of microscopic quantum links. In this view, gravity, curvature, even distance emerge from how information is entangled. If you could somehow untangle the universe completely, space and time might dissolve. Such ideas merge physics with philosophy. They suggest that connection is not merely a metaphor, it's the essence of being. Everything we see, touch, and think is part of an immense network of correlations reaching back to the birth of the cosmos. When the Big Bang occurred, every particle was once in intimate contact with every other. As the universe expanded, those relationships stretched but never fully broke. On some deep level, every atom in your body still carries the imprint of that original unity. The carbon in your cells was forged in the heart of long-dead stars. The calcium in your bones once belonged to a supernova. The oxygen you breathe was produced by ancient plants that captured sunlight, a quantum process itself. Entanglement reminds us that we are not separate observers of the cosmos but active participants woven from its same quantum threads. Einstein eventually came to accept that even if he disliked quantum non-locality, the experiments left no escape. His equations of relativity describe the large-scale structure of spacetime. Quantum theory describes the small-scale probabilities of matter. Both are true, and both hint at a deeper unity still beyond our grasp. Perhaps that unity is the real message of entanglement. The cosmos is one, and division is an illusion of scale. When we peer through the lens of quantum physics, the universe reveals itself not as a clockwork of isolated parts, but as a shimmering web of interdependence. And maybe, just maybe, the same principle governs the mysterious connection between the human mind and the world it perceives. Thought, awareness, and matter may be different expressions of a single underlying reality, one that is fundamentally relational. Entanglement, then, is not merely a physical phenomenon. It's a clue to the architecture of existence. It tells us that what happens anywhere affects what happens everywhere. The distant galaxy you glimpse through a telescope, the photon striking your retina, the neural signal it triggers, all of it is part of one continuous event unfolding in spacetime. As our understanding deepens, the border between physics and metaphysics blurs. The equations are clear, but their implications remain astonishing. There may be no real distance in the way we imagine. Information and influence might be woven through a higher dimensional order beyond space and time itself. In the quiet of that realization, we begin to see the universe differently. Every atom becomes a messenger from the whole, every thought, a ripple in the cosmic field. To study entanglement is to glimpse the unity that underlies diversity, the invisible harmony that connects galaxies, particles, and minds. In the end, the lesson of quantum entanglement is simple yet profound. Nothing truly stands alone. From the birth of the universe to the firing of a single neuron, existence is an endless conversation among interwoven parts of a single reality. And when we look up at the stars, what we see shining back is not a distant other, but another expression of the same cosmic self, an entangled universe reflecting on itself through us. Is the brain a quantum computer? The human brain is often described as the most complex structure in the known universe. Inside its 3 pounds of tissue lie about 86 billion neurons, each forming thousands of connections, communicating through electrical and chemical signals. From these interactions emerge thought, emotion, memory, creativity, and consciousness itself. For centuries, we've compared the brain to the most advanced machines of each era. In the 17th century, it was a clockwork mechanism. In the 19th, a telegraph system. Today, we compare it to a computer, a biological processor made of wetware instead of hardware. But could that analogy be more literal than we realize? Could the brain, at some level, actually operate like a quantum computer? To understand this question, we must first understand what a quantum computer is, and why it's so different from any classical machine. A traditional computer, like the one you're using now, processes information in bits, units that can be either 0 or 1. Every calculation, every video frame, every message is ultimately built from these binary states, flipping on and off in sequence. A quantum computer, however, uses qubits, quantum bits, which can exist in a superposition of both 0 and 1 simultaneously. This means that instead of performing one calculation at a time, a quantum computer can explore many possibilities in parallel. When the superposition collapses, the result reflects the combined influence of all those simultaneous computations. Entanglement takes this even further. When qubits become entangled, their states are linked no matter how far apart they are. Changing one instantly affects the other. This allows quantum computers to process information in ways that classical logic cannot imitate, weaving connections through the abstract fabric of quantum probability. Now, imagine if the human brain were capable of harnessing similar principles. If its neurons, or even subcellular structures within them, could maintain quantum coherence, the delicate superposition of states, then the mind might operate not just as a classical network of electrical impulses, but as a quantum information processor. This idea has fascinated scientists and philosophers alike. It would help explain mysteries that classical neuroscience struggles with, how the brain integrates billions of signals into a unified moment of experience, how creativity and intuition seem to draw on hidden patterns, why consciousness feels instantaneous and holistic rather than step by step. In the 1990s, physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed one of the boldest versions of this idea, the orchestrated objective reduction, OR theory. They suggested that quantum processes occurring within microtubules, tiny tubular structures inside neurons, could form the basis of consciousness. Microtubules are part of the cell's cytoskeleton, maintaining its shape and helping with transport and division. But Hameroff noticed that their internal geometry is extraordinarily regular and complex, capable of sustaining oscillations and information flows. Penrose added a quantum twist. Perhaps these structures allow for coherent quantum states, tiny quantum computations, that collapse according to gravitational effects described by Penrose's own theory of quantum gravity. In the OR model, each collapse corresponds to a moment of conscious experience. Billions of these quantum events across neural networks could collectively create the flowing continuity we perceive as awareness. Critics were quick to respond. Quantum coherence is notoriously fragile, easily disrupted by heat and noise. The brain, operating at around 37 degrees C and bathed in water and ions, seems like the last place quantum states could survive. Physicist Max Tegmark once calculated that any quantum superposition in the brain would decohere within trillionths of a second, far too fast to influence neural activity. Yet the debate didn't end there. In recent years, new research has challenged those assumptions. Studies in quantum biology have revealed that living systems can, in fact, sustain quantum effects. In photosynthesis, for example, energy captured from light appears to move through plant molecules via quantum coherence, finding the most efficient path. Birds, too, may use quantum entanglement in their retinas to navigate Earth's magnetic field. If evolution has already harnessed quantum mechanics for efficiency in plants and animals, could it have found similar ways to enhance information processing in the brain? In 2013, a team at the University of Ulm discovered quantum vibrations within microtubules, lasting much longer than previously expected. These findings, though not conclusive, reignited curiosity about quantum brain dynamics. Even if the brain doesn't function as a full quantum computer, it might use quantum effects to optimize certain processes, bridging the gap between classical and quantum information. The appeal of this idea is clear. Quantum computing offers enormous power because it operates in a space of probabilities, not certainties. The human mind seems to do the same. We don't make decisions through strict logic alone. We consider possibilities, hold contradictory ideas in tension, and collapse them into choices that feel both reasoned and intuitive. When a musician improvises, or a scientist envisions a theory, or you suddenly solve a problem you've pondered for days, those leaps may reflect the brain's ability to process information in a highly parallel probabilistic way, much like quantum computation. Another connection lies in quantum tunneling, the phenomenon where particles pass through energy barriers they shouldn't, according to classical physics. In neurons, tiny ion channels control the flow of charge that creates electrical impulses. Some research suggests that quantum tunneling might help ions move through these channels faster than diffusion allows, subtly influencing neural timing and synchronization. If that's true, then even basic thought patterns could depend on quantum events, randomness at the smallest scales creating coherence at the largest. Still, the quantum brain hypothesis remains controversial. Many neuroscientists argue that classical models are sufficient to explain cognition. The brain's complexity alone, they say, produces emergent intelligence without needing quantum magic. Yet others point out that the line between classical and quantum may not be as rigid as once thought. At the deepest level, every atom in the brain obeys quantum laws. Synaptic vesicles, neurotransmitters, ions, and electrons all move in probabilistic patterns. Whether or not consciousness itself depends on quantum computation, the machinery of thought is undeniably quantum mechanical. What's truly remarkable is that the brain, built from these quantum components, has evolved to model the very universe that created it. Through the equations of physics and the logic of mathematics, the mind contemplates the same rules that govern its own atoms, a recursive loop of awareness through which the universe understands itself. Quantum computers and human minds share another intriguing property. Both rely on coherence and collapse. In quantum systems, coherence allows superposition, the exploration of possibilities, and collapse selects a result. In thought, we hold ideas, options, and scenarios in mental superposition before collapsing them into a decision or insight. Perhaps this parallel isn't accidental, but a reflection of how information naturally behaves in a quantum reality. If consciousness does emerge from quantum processes, it could also help explain one of the greatest puzzles in neuroscience: the binding problem, how the brain unites color, sound, emotion, and meaning into a single experience. Classical communication between neurons, limited by synaptic speed, may not be fast enough to synchronize billions of features into a cohesive now. But quantum entanglement, operating instantaneously, could provide a mechanism for global coherence across neural networks. The implications stretch far beyond biology. If the brain is, in any sense, a quantum computer, then consciousness might not be confined to organic matter. Future machines designed to exploit quantum coherence could one day emulate, or even participate in conscious experience. Imagine an artificial intelligence running on a quantum processor, capable of perceiving superposed possibilities, sensing probabilities, and perhaps developing a kind of awareness rooted in the same physics as our own. Such a development would force humanity to reconsider the boundaries between mind, matter, and machine. But even without speculative leaps, the quantum perspective reframes how we see ourselves. It reminds us that thought is not separate from nature. Every flash of insight, every emotion, every perception is a quantum event, the universe, in miniature, performing computation through the chemistry of consciousness. When we look at the stars and wonder about our place among them, that very wonder is the cosmos thinking about itself through quantum brains evolved from stardust. The observer and the observed, the question and the answer, are part of the same quantum process unfolding across scales. Perhaps, then, asking whether the brain is a quantum computer is really asking whether the universe itself computes, whether reality is the ultimate quantum processor, and our minds are local nodes in its vast network of awareness. In that light, consciousness is not an anomaly of biology but an intrinsic property of existence, the result of quantum information organizing itself into self-reflective patterns. Whether or not the brain uses quantum coherence as a mechanism, its emergence from quantum matter is undeniable. We are quantum beings, built from quantum processes, perceiving a quantum universe. And maybe, just maybe, that is why we can comprehend it. The quantum field of consciousness. Imagine for a moment that the universe isn't made of things but of relationships. That underneath every atom, every particle, and every beam of light, there is a field, invisible, continuous, and ever-present. This field doesn't merely exist in space. It is space. It ripples and vibrates, giving rise to the particles and forces that shape everything we see. Physicists call this the quantum field, the fundamental bedrock of reality. Every electron in your body is an excitation of the electron field. Every photon that touches your skin is a vibration of the electromagnetic field. These fields permeate all of space, interacting and overlapping, weaving a tapestry of energy from which matter, light, and life emerge. Now imagine that your brain, your seat of thought and awareness, is not separate from these fields, but a localized organization of them. What if consciousness itself is not confined to the skull, but is part of the same quantum fabric that spans the cosmos? This is the idea at the heart of what some scientists and philosophers call the quantum field of consciousness. It's a perspective that blurs the line between physics and mind, suggesting that awareness may not merely arise from the universe. It may be one of its fundamental expressions. To understand this possibility, let's revisit the quantum field theory that revolutionized modern physics. In quantum field theory, particles are not isolated objects flying through space. Instead, they are excitations, waves in underlying fields. When an electron moves, it's not a point particle darting around, but a disturbance in the electron field spreading through spacetime. Every interaction, every collision, every bit of light that reaches your eyes is a dance of fields, vibrating, exchanging quanta of energy. When we zoom in on the brain at the deepest level, we find the same thing. Neurons are made of atoms, which are made of subatomic particles, which are ripples in quantum fields. The electric currents that run through your neural circuits are flows of these same quantum excitations. So, what separates the physical universe from the mental one, the neuron from the thought, the photon from perception? Perhaps nothing at all. Perhaps consciousness is a pattern emerging from quantum coherence within these universal fields. Consider this analogy. Imagine an ocean that stretches endlessly in every direction. On its surface, waves rise and fall, distinct, dynamic, and ever-changing. Some are small ripples, others are vast swells that travel across great distances. Each wave seems separate, yet all are part of the same body of water, Now, replace that ocean with the quantum field and the waves with individual minds. Each consciousness could be seen as a localized excitation, a unique expression of the universal field of awareness. When we quiet our thoughts, meditate, or simply observe without judgment, perhaps we're tuning into the stillness beneath the waves, the calm depth of the field itself. This view echoes ancient philosophical traditions. In Vedanta, it is said that Atman is Brahman, the self is one with the universe. In Taoism, consciousness flows with the Tao, the underlying order of existence. And in modern physics, we find a strange resonance. The quantum field behaves in ways that defy separation and individuality. Particles don't exist independently. They exist as probabilities, as entangled possibilities within a shared wave function. When one collapses into a definite state through observation, it affects others instantly, regardless of distance. This phenomenon, known as quantum entanglement, might hint at a deeper unity, a hidden web connecting all systems. If every particle in your body was once entangled with those in the early universe, could your consciousness, too, still be connected to that cosmic whole? Physicist David Bohm believed so. In his interpretation of quantum mechanics, reality consists of two orders: the explicate order, which is the visible material world, and the implicate order, a deeper, hidden realm where everything is enfolded into everything else. Bohm suggested that consciousness and matter arise together from this implicate order, like ripples emerging from an invisible current. In his view, the mind is not a separate entity, but a manifestation of the same quantum wholeness that shapes all matter. This means that every thought, every emotion, every act of perception could be the visible unfolding of an underlying quantum process, a movement within the universal field. Now imagine that instead of your brain generating consciousness like a light bulb, it's more like a radio receiver, tuning into and modulating the frequency of this field. Your neural networks would act as complex quantum interfaces, translating the infinite potential of the field into the finite experience of awareness. This analogy isn't purely metaphorical. Recent discoveries suggest that the brain operates near a critical threshold between order and chaos, a state physicists call criticality. Systems at criticality can exhibit complex patterns that are highly sensitive to small fluctuations, much like quantum systems. In such a state, even tiny quantum variations might be amplified into macroscopic effects, influencing neural activity and cognition. This could allow the brain to resonate with the quantum field, maintaining coherence across large networks without losing flexibility. If true, consciousness may be less about computation and more about connection, the ability of the brain to align itself with a deeper informational structure of reality. We see hints of this in phenomena like intuition, creativity, and sudden insight, moments when knowledge seems to arise spontaneously, as if drawn from a source beyond the individual mind. Could it be that the brain, in these moments, synchronizes with the field, accessing information embedded in the fabric of the cosmos itself? Quantum field consciousness doesn't require mysticism. It simply extends physics to its logical conclusion. If everything in existence emerges from quantum fields, then so must consciousness. The difference is that consciousness may also influence those fields through observation. This brings us back to one of the most mysterious aspects of quantum mechanics, the observer effect. In experiments like the double-slit test, particles behave as waves until they are observed, at which point they choose a definite path. The mere act of measurement of awareness seems to collapse possibilities into actuality. What if consciousness is not just a byproduct of quantum behavior, but an integral part of it? What if observation isn't something that happens to the universe, but something the universe does through us? Under this view, the cosmos is not a cold, indifferent mechanism, but a living field of awareness continuously observing, evolving, and expressing itself. Our brains are not isolated islands of consciousness, but apertures through which the universe experiences itself from countless perspectives. When you look up at the stars, it's not merely you witnessing the universe, it's the universe through you, gazing back at itself. modern physics is beginning to hint at this unity. Quantum information theory suggests that information, not matter or energy, might be the fundamental substrate of reality. If consciousness is the processing and experience of information, then it too may be as fundamental as spacetime itself. Physicists like John Wheeler propose that the universe is a participatory one, that observers help bring reality into being. His phrase, "it from bit," captures this idea. Physical reality arises from informational choices, from yes or no decisions made at the quantum level. Could our awareness, our conscious choices, be part of that same creative process? If so, consciousness might not be an accidental byproduct of evolution, but a necessary feature of the universe, a mechanism through which reality explores its own possibilities. In this sense, the quantum field of consciousness is not confined to humans or even to life as we know it. Every system that can participate in quantum information exchange could, in principle, share in this universal awareness. From atoms and molecules to galaxies and black holes, consciousness, then, becomes not something we possess, but something we are part of, a cosmic continuum that expresses itself through countless forms. And when we meditate, reflect, or simply become still, perhaps we reconnect with that continuum, feeling the faint hum of the quantum field that has been vibrating since the dawn of time. In that stillness, awareness expands beyond the boundaries of self and body. The distinction between observer and observed begins to fade. What remains is a sense of unity, the quiet recognition that we are the universe, aware of itself. Perhaps this is what the great physicist Erwin Schrödinger meant when he said, "The total number of minds in the universe is one." From this perspective, consciousness is not generated by the brain. It flows through it like a current passing through a finely tuned instrument. The music of thought, emotion, and imagination is the resonance of the cosmic field, expressed in human form. And as science advances, we may come to realize that exploring the mind is not separate from exploring the universe. They are two sides of the same quantum coin, both emerging from the same infinite ocean of potential. Entanglement and the universal mind. What if every spark of awareness in the cosmos is part of one vast, interconnected consciousness, threads of a single universal mind, entangled across space and time? Modern physics gives us an unexpected reason to take that idea seriously. At the heart of quantum theory lies entanglement, a bond so deep that two particles can share one physical state no matter how far apart they drift. Change one, and the other responds instantly, as though distance doesn't exist. To Einstein, this was spooky action at a distance. To today's physicists, it is a measured, repeatable fact of nature. But what does that mean for us? Every atom in your body, every neuron firing in your brain, emerged from the same early universe that once existed as a single, ultra-dense quantum soup. Before expansion scattered matter into stars and planets, everything was entangled. Perhaps that ancient linkage never truly vanished. Perhaps it still hums beneath the surface of reality, connecting every living mind to the same cosmic field. Some researchers call this field the quantum vacuum, others the zero-point field. It's not empty. It seethes with virtual particles flickering in and out of existence, a restless sea of energy. Every subatomic interaction occurs within it. If consciousness is a property of the universe, this field could be its medium, the invisible web through which information travels instantly and silently. Now consider the brain, an intricate network of 86 billion neurons, synchronized through oscillations and electrical pulses. The patterns of these pulses form what neuroscientists call neural coherence, the harmony of brain rhythms that gives rise to thought and perception. At the quantum scale, coherence has another meaning: particles vibrating in perfect phase, maintaining unity even when separated. Could neural coherence and quantum coherence be two faces of the same principle? The orchestrated objective reduction theory, OR, proposed by Roger Penrose and Stuart Hameroff, suggests they might be. It argues that microtubules inside neurons sustain brief quantum states that collapse in orchestrated patterns, producing moments of conscious awareness. Each collapse could be a small-scale entanglement event between the brain and the quantum field itself. While this hypothesis remains debated, it invites a radical possibility that consciousness is not confined to individual brains but arises from an ongoing dialogue between mind and cosmos. When you think, feel, or dream, you may be participating in a universal quantum conversation. Across cultures, ancient traditions have spoken of this shared mind in poetic terms: the Akashic field, the collective unconscious, the ocean of spirit. Science, with new language and equations, may be approaching the same shoreline from another direction. If entanglement extends beyond particles to systems as complex as living brains, then empathy, intuition, even creativity could be natural expressions of quantum connection. A thought born in one mind might ripple subtly through the field, influencing another far away. We glimpse faint evidence of this in studies of group synchronization, musicians keeping tempo without cues, meditators' heartbeats aligning, crowds moving as one. Beneath behavior and biology, a deeper coherence may be at work. Physicist David Bohm offered a vision that bridges science and spirituality. He described the universe as a single, undivided whole, the implicate order, from which the visible world unfolds like patterns on the surface of a vast sea. In this model, each fragment of reality contains the whole, just as every drop of water contains the chemical signature of the ocean. Consciousness, he believed, is the universe becoming aware of that wholeness within itself. In a sense, entanglement is the physical fingerprint of Bohm's implicate order. It tells us that the parts of reality are never truly separate. They are projections of one underlying unity. The universal mind is not somewhere out there. It is the totality of information woven through every quark and neuron, every galaxy and thought. So when you close your eyes and listen inwardly, when you sense inspiration arriving from nowhere, that nowhere may be the everywhere of quantum reality. Your consciousness may be resonating with the universal field, just as one tuning fork vibrates when another across the room is struck. Imagine trillions of minds as countless instruments in a cosmic orchestra. Each plays a unique melody, yet all are tuned to the same quantum frequency. The music we call existence is the sum of those resonances, matter, energy, and awareness dancing as one. This idea does not diminish individuality, it deepens it. A single note gains meaning only within a symphony. Likewise, your personal consciousness is a localized focus through which the universe experiences itself in a particular way. You are both a participant and an expression of the whole. As quantum science advances, we may someday detect subtle signatures of this entanglement, correlations between distant minds or biological systems that defy classical explanation. For now, it remains a frontier of speculation and wonder. But even in theory, it changes how we see ourselves. You are not an isolated observer staring out at a mechanical universe. You are part of the universe observing itself. Every perception, every act of awareness, is a mirror in which the cosmos recognizes its own reflection. Perhaps this is what the mystics meant when they said, "The drop is the ocean, and the ocean is the drop." In quantum terms, the particle and the field are one. In human terms, the mind and the universe are inseparable. And when we finally grasp that truth, not just intellectually, but experientially, we may understand that entanglement is more than a scientific fact. It is the signature of the universal mind, the evidence that consciousness is not a late-arriving accident in a lifeless cosmos, but the very essence from which the cosmos unfolds: dreams, intuition, and quantum states of mind. Have you ever wondered where dreams come from? Not just what they mean, but what they are physically, biologically, and perhaps quantumly. When you close your eyes at night and drift into that vast inner cinema of shifting realities, what exactly is happening in your brain, and could it be more than just neurons firing? Dreams have fascinated humanity since the dawn of consciousness. Ancient civilizations saw them as messages from the divine. Freud viewed them as windows into the subconscious. Modern neuroscience describes them as patterns of electrical activity that consolidate memories and emotions. But as we dive deeper into the mysteries of consciousness, another possibility begins to shimmer at the edges of understanding, that dreams may be expressions of the brain interacting with quantum states of mind. Let's begin with what we know. During REM sleep, the rapid eye movement stage, the brain becomes highly active. Neurons in the visual and emotional centers fire intensely, while the logical prefrontal cortex rests. This creates a state of vivid imagery unrestrained by rational control. In this twilight realm, time stretches, physics bends, and self-awareness becomes fluid. Yet, this state is remarkably similar to descriptions of altered consciousness in meditation, psychedelics, and even quantum theories of perception. Some scientists, like physicist Roger Penrose and anesthesiologist Stuart Hameroff, propose that consciousness itself arises from quantum processes in microtubules within neurons, tiny protein structures that may support quantum coherence. If true, dreams could be periods when the brain dips into these quantum fields more freely, unbounded by waking constraints. In sleep, the brain's filters quiet down, allowing deeper layers of mind to resonate with subtler patterns of reality. Consider intuition, that sudden, unexplainable knowing that emerges without logic or evidence. You just know and later discover you were right. Could intuition be the waking cousin of the dream state, a moment when consciousness briefly connects with a quantum information field? Some researchers call this the quantum intuition hypothesis, suggesting that our subconscious mind might access probabilistic patterns, the kind found in the quantum world, before the rational brain catches up. Dreams, then, may serve as a bridge between two modes of knowing, the linear, classical awareness of waking life and the nonlinear, multidimensional awareness of quantum consciousness. In the dream world, information is not processed step by step, but experienced all at once, symbolically, emotionally, energetically. That is how quantum systems behave too, not as definite events, but as waves of potentiality collapsing into temporary realities. When you dream, your mind paints possibilities, just like the universe itself does through the quantum wave function. And when you wake, your consciousness collapses those possibilities into the narrative of self and story. What if every dream is a rehearsal for creation? A nightly reminder that reality itself begins as imagination, that your thoughts, perceptions, and choices are all part of a cosmic act of observation. In this sense, dreams are not illusions. They are messages from the deeper field of being. They remind us that reality is not fixed, that consciousness is not confined to the brain, and that intuition may be our most direct way of touching the infinite. From the ancient seers who interpreted dreams as glimpses of higher realms, to modern quantum theorists exploring the informational substrate of the cosmos, one idea echoes through time, that the mind is not just in the body, but that the body and even the universe itself may exist within the mind. And so, as you drift to sleep tonight, remember, you are not merely resting. You are re-entering the field of creation, where consciousness explores its own depths. You are both the dreamer and the dream, the observer and the observed, a living quantum wave in the ocean of infinite awareness. What if consciousness is not an accident of biology, but the very foundation of existence itself? What if the universe is not a vast collection of cold, meaningless matter, but a living field of awareness, and we are its self-aware expressions? This question, is the universe conscious, has fascinated philosophers, physicists, and mystics alike. It bridges science and spirituality, challenging the most fundamental assumption of modern thought, that matter gives rise to mind. But what if it's the other way around? What if mind gives rise to matter? Let's begin with a simple yet profound realization. Everything we know about the universe, every star, every particle, every law of physics has reached us only through consciousness. Without awareness, there is no observation. Without observation, no measurement. And without measurement, according to quantum physics, there is no definite reality. In the quantum realm, particles exist in a superposition, a haze of probabilities, until they are observed. When an observer looks, the wave collapses into a specific outcome. This observer effect has led many to wonder, does consciousness play a role in creating reality itself? Physicist John Wheeler once proposed the idea of the participatory universe, that the cosmos requires observers to bring it into being. In his words, we are participants in bringing about something of the universe in the distant past. It's a bold idea, that reality is not fully formed without the conscious participation of minds within it. If this is true, then consciousness is not localized to individual brains but woven into the very structure of the cosmos. Every atom, every quantum fluctuation, may carry within it a spark of awareness, a pulse of the universal mind. This perspective aligns with a concept known as panpsychism, the view that consciousness is a fundamental feature of reality like space, time, and energy. According to panpsychism, everything possesses some degree of experience, even if incredibly faint. The universe is not dead, it's awake everywhere. In this light, human consciousness is not unique, but an expression of a much larger intelligence, the universe becoming aware of itself through us. Our thoughts, emotions, and perceptions are the microcosmic reflections of the cosmic mind. When we look at the stars, the universe looks back through our eyes. Modern physics offers intriguing parallels to this idea. The fabric of reality, the quantum field, is a vast ocean of energy and information. Everything we see, from galaxies to cells, emerges as ripples in this field. Some theorists, like physicist David Bohm, describe this as the implicate order, a deeper, hidden layer of reality where everything is interconnected, and consciousness may reside. To Bohm, the universe is a hologram, each part containing the whole. If that's true, then consciousness, too, is holographic. Every human mind holds within it the entire blueprint of the cosmos, just as every drop of ocean water reflects the sea. This notion echoes ancient wisdom traditions. In Hindu philosophy, the concept of Brahman refers to the universal consciousness, the infinite reality from which all existence arises. In Buddhism, awareness is seen as the ground of being, empty yet luminous, the source of all phenomena. Mystics have long claimed what physicists are only beginning to suspect, that consciousness is not produced by matter but precedes it. When viewed this way, the universe becomes a vast living organism, evolving, sensing, and knowing itself through the countless forms of life it generates. Stars are its neurons, galaxies its clusters of thought, and you, the observer, are a synapse in its cosmic brain. It is a humbling yet liberating thought, that we are not separate from the universe but expressions of its awareness, localized for a time in human form. The same consciousness that breathes through the galaxies breathes through you. The same intelligence that shaped the stars beats within your heart. And when you quiet your mind, when thoughts slow and boundaries dissolve, you begin to feel it. The stillness that remains is not emptiness. It's the living silence of the universe remembering itself through you. In that silence, you are not just observing the cosmos, you are the cosmos conscious of itself. Soft ambient swell, a resonant hum, like the pulse of deep space. Everything that exists is awareness taking shape. Every moment is consciousness folding into form. You are not in the universe is in you. Ancient wisdom meets quantum science. Across thousands of years, humanity has gazed at the stars and asked the same question. What is the nature of reality? Before quantum physics, before modern neuroscience, ancient civilizations sought answers not through equations, but through inner exploration. Through meditation, intuition, and sacred ritual, they tried to understand what today's scientists probe with particle accelerators and telescopes, the invisible fabric of existence. And now, as modern science delves deeper into the mysteries of quantum mechanics and consciousness, something extraordinary is happening. Ancient wisdom and cutting-edge physics are beginning to speak the same language. Let's begin with one of the oldest insights known to humankind, the principle of unity. Ancient sages from the Upanishads in India declared, Tat Tvam Asi, thou art that. It means, The self and the universe are one. Everything that exists arises from the same eternal consciousness, taking countless forms but never losing its essence. Thousands of years later, quantum physics tells a strikingly similar story. Beneath the diversity of matter, everything is made of the same fundamental substance, energy. The particles that form your body are no different from those that make up the stars. At the quantum level, boundaries dissolve. All things are connected through the unified field. The mystics described it as Brahman, the eternal reality. Physicists call it the quantum field. Two names for one truth, that all of existence emerges from a single, undivided source. Consider this. When the Buddha spoke of dependent origination, he meant that nothing exists independently. Every event, every being, arises in relationship to everything else. In quantum terms, this mirrors the principle of entanglement, the idea that once two particles interact, their states remain connected across space and time. Change one, and the other responds instantly, no matter how far apart. Ancient insight, modern proof. For centuries, mystics have said that the separation between self and world is an illusion, Maya. They taught that reality, as we perceive it, is not solid, but a play of energy and awareness. In the quantum world, this too appears true. What seems like solid matter is mostly empty space. The chair you sit on, the air you breathe, even your own body, all are vibrating fields of energy, sustained by invisible quantum interactions. Pythagoras once said, "All is number." He believed that the universe is governed by mathematical harmony, that everything vibrates with proportion and rhythm. Today, quantum physicists describe particles as vibrations of fields, oscillations at precise frequencies that give rise to mass, light, and form. String theory even suggests that the fundamental building blocks of reality are one-dimensional vibrating strings. The ancient mystics would nod knowingly. They too spoke of the music of the spheres, the divine sound that holds creation together. In ancient Egypt, the concept of Ka, the vital essence, described an unseen life force flowing through all beings. In China, it was Qi, the breath of life. In India, Prana. These were early understandings of the same universal energy modern physics now studies as the electromagnetic and quantum fields. When a yogi meditates, they quiet the fluctuations of the mind to experience the underlying stillness of being. When a quantum physicist observes a system, they must also quiet the disturbance of measurement to glimpse the system's pure potential state. Both are seeking the same essence, the unobserved source of reality before it collapses into form. Let's not forget the power of observation, central to both spirituality and science. The Upanishads say, "As is the microcosm, so is the macrocosm." Quantum physics echoes this with the observer effect, where the very act of observing influences what is observed. Consciousness and reality, forever entwined. Even the language of quantum theory, uncertainty, probability, superposition, mirrors the fluidity of ancient metaphysics. The Tao Te Ching says, "The Tao that can be named is not the eternal Tao." Reality, at its core, is undefinable, not fixed, but flowing. The same mystery that Lao Tzu spoke of now reveals itself in the uncertainty principle of Heisenberg. Ancient seers journeyed inward to discover the cosmos within. Modern scientists journey outward, exploring the universe through technology. Yet both paths lead to the same realization, that the observer and the observed are one continuous whole. What we call matter may simply be consciousness observing itself, playing the grand cosmic game of becoming. Imagine, for a moment, a meeting between a quantum physicist and a Vedic sage. The physicist speaks of wave function collapse. The sage replies, "Yes, when the mind stops, the world appears." The physicist describes quantum entanglement. The sage smiles and says, "All is one." The physicist mentions the quantum vacuum, seething with energy. The sage calls it shunyata, the fertile emptiness that gives birth to all things. Different words, same truth. Perhaps science and spirituality were never opposites, but complementary ways of perceiving the same infinite mystery, two eyes of the same cosmic being. As quantum science continues to unfold, the gap between laboratory and monastery, between experiment and experience, grows smaller. The equations of physics and the poetry of the mystics both point toward the same realization, that consciousness is not a byproduct of matter, but the essence of existence itself. The ancients intuited it. Quantum science is rediscovering it, and you, through awareness, are living proof of it. When you breathe, the universe breathes through you. When you think, the universe contemplates itself. And when you awaken, even for a moment, to the unity of all things, you are fulfilling the oldest truth that you are not in the cosmos. You are the cosmos, aware of itself through human eyes. Consciousness beyond the brain. We've spent centuries believing that consciousness is something generated by the brain, that the mind is what the brain does. But what if that assumption is only part of the story? What if consciousness doesn't emerge from the brain, but instead, the brain acts as a receiver, a filter, or a tuner of a much larger field of awareness that exists beyond it? This is the great frontier of modern science, and perhaps the most profound question of existence. Is consciousness a product of biology, or is biology a product of consciousness? Let's begin with what we know. The brain is a masterpiece of evolution. 100 billion neurons communicating through trillions of synapses. Electrical and chemical signals give rise to perception, thought, and memory. Yet, even the most detailed neuroscience cannot explain the hard problem of consciousness. The mystery of how subjective experience, the inner world of color, taste, and emotion, arises from mere physical matter. You can map every neural connection, simulate brain functions on computers, and still, the question remains: why does it feel like something to be alive? This is where the idea of consciousness beyond the brain enters the discussion. Many scientists, philosophers, and mystics propose that consciousness is not produced by the brain. It is fundamental, omnipresent, and the brain merely interfaces with it. Imagine a radio. The sounds you hear do not originate from the radio itself. They are broadcast waves received and decoded by it. Break the radio, and the signal remains, though you can no longer hear it. Perhaps the brain works the same way, not generating consciousness, but channeling it from a deeper field that pervades the universe. This concept is supported by several modern frameworks. One is the field theory of consciousness, which suggests that awareness is a universal field, much like the electromagnetic field, and the brain interacts with it much as an antenna interacts with radio frequencies. Another is integrated information theory, IIT, developed by neuroscientist Giulio Tononi. IIT proposes that consciousness is not limited to biological systems. It arises wherever there is integrated information. Even the simplest network, if sufficiently interconnected, possesses some degree of awareness. That means consciousness could be a property of the universe itself, inherent in all systems that hold and process information. If so, your mind is not trapped within your skull. It is part of a continuum of awareness stretching across space and time. This idea isn't new. In ancient philosophies, consciousness was always seen as primary. The Vedas called it Atman, the eternal self that exists beyond birth and death. In Buddhism, awareness is boundless, not something owned by an individual, but a vast field that manifests through each living form. In many indigenous traditions, the earth, the stars, even stones and rivers are seen as alive, conscious expressions of the same cosmic intelligence. Modern research offers intriguing hints. Near-death experiences, for example, report vivid awareness even when brain activity ceases. Patients describe floating above their bodies, perceiving details later confirmed to be accurate. While controversial, such accounts raise profound questions. How can consciousness persist when the brain is offline? Similarly, quantum biology suggests that processes within the brain, such as coherence in microtubules, may operate at quantum scales. If the brain taps into the quantum field, then consciousness may exist in that field as well, beyond space and time. The physicist Erwin Schrödinger once wrote, "The total number of minds in the universe is one." What we call individual consciousness may simply be localized expressions of a single universal awareness, filtered through biological forms, much like sunlight passing through different windows. When we dream, meditate, or experience deep transcendence, those filters loosen. We begin to sense that consciousness is not confined within us, but rather that we exist within consciousness. It is a shift from seeing the mind as in the body to realizing the body is in the mind. In quantum terms, consciousness might be the field that allows all particles and waves to exist and relate. It's the invisible canvas on which all of reality is painted. Without it, there is no observation and thus no existence. And this has deep implications for how we see life, death, and meaning itself. If consciousness is fundamental, then death may not be an end but a transition, a change in state, like water returning to vapor. The individual mind dissolves, but awareness itself, the field, continues, eternal and infinite. This vision aligns science with spirituality in a breathtaking way. It invites us to see ourselves not as isolated thinkers trapped in fragile bodies, but as expressions of the cosmos becoming aware of itself. When you look at a sunset, the universe is watching its own beauty through your eyes. When you think, love, or dream, you are the infinite consciousness exploring its own potential through the lens of human experience. The brain, magnificent as it is, may be just the instrument and consciousness, the musician. So perhaps the real question is not whether consciousness exists beyond the brain, but whether the brain has ever truly been separate from it. Because in the end, consciousness may not be inside you at all. You are inside it. Energy, vibration, and the quantum field, everything in existence vibrates. From the smallest atom to the largest galaxy, the universe is a symphony of motion, waves of energy dancing in infinite patterns. Matter, as we know it, is not truly solid. It is vibration, condensed energy, resonating at frequencies that define form. Modern physics confirms what ancient wisdom taught for millennia, that energy is the foundation of all things. What we perceive as separate objects, the chair, the tree, the stars, are simply fluctuations in an invisible sea of energy known as the quantum field. This field permeates everything, everywhere. It is the source from which all particles arise and to which they eventually return. In this vast energetic ocean, there is no real separation. Every atom in your body is connected to every atom in the cosmos through subtle waves of vibration. When you move, think, or breathe, you are in constant resonance with the entire universe. Let's explore this deeper. At the heart of quantum theory lies a beautiful truth. Particles do not exist as tiny, independent objects. They exist as waves of probability, ripples in a field of pure potential. Only when observed do these waves appear as definite particles. What you are seeing, touching, and interacting with is not static matter but stabilized energy, consciousness manifesting as vibration. Physicist Max Planck, the father of quantum theory, once said, "All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind." Planck intuited that behind every particle, every vibration, there is intelligence, consciousness guiding energy into form. In this light, the quantum field is not merely physical, it is aware. It responds to observation, attention, and intention. This is not mysticism, but a reflection of one of the most puzzling discoveries in physics, that the observer and the observed are inseparable. When you observe a quantum system, you influence it. When you focus your awareness, you are, in some subtle way, shaping the very energy of reality. This is where ancient understanding begins to mirror modern science. The sages of India spoke of prana, the life energy that flows through all things. In China, it was called qi, the vital breath. In many spiritual traditions, this force was seen as both physical and spiritual, the bridge between matter and consciousness. Today, we might call it the quantum field, the unifying energy that animates the cosmos. And vibration, it is the language of that field. Every thought, every emotion, every sound emits a frequency that interacts with this ocean of energy. Your heart has its rhythm, your brain its frequency, and your cells resonate with the subtle music of life. When you feel peace, gratitude, or love, your body emits coherent, harmonious vibrations. When you experience anger or fear, the frequency becomes chaotic and disordered. This isn't poetic imagery, it's measurable. Research in heart-brain coherence and biophysics shows that emotional states can alter electromagnetic patterns, influencing not only your health but your surrounding energetic environment. It seems the universe does not only hear what you say, it feels what you vibrate. Everything from a photon of light to a thought of compassion has a signature frequency. Nikola Tesla famously said, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." He was right. At its deepest level, the universe is not a collection of things but a network of resonances, harmonics of energy intertwined like notes in an endless cosmic song. Each atom hums, each molecule sings, and together they form the grand orchestra of creation. This is why meditation, music, and sacred sound have been used for centuries to alter consciousness. Chanting Om, striking a singing bowl, or sitting in silence are all ways of tuning your awareness to the vibration of the field. These practices quiet the noise of mental interference, allowing your consciousness to resonate more closely with the subtle hum of existence itself. When your internal vibration aligns with the natural frequencies of the universe, you experience harmony, physically, emotionally, and spiritually. You feel connected, expansive, whole. And this harmony is not metaphorical. Studies on quantum coherence suggest that systems operating in resonance, from photosynthetic cells to the human brain, can communicate energy and information instantly without loss. Coherence amplifies connection. It creates unity from chaos. So imagine consciousness itself as a tuning fork. When you think, you strike the fork. The vibration that follows travels through the quantum field, influencing patterns of probability, subtly shaping the unfolding of your personal reality. This idea bridges physics and mysticism beautifully. The quantum field, filled with infinite potential, may respond to the vibration of consciousness, collapsing possibilities into the patterns that match your energetic frequency. You attract, in essence, not what you want, but what you are. Every emotion, every belief, every thought carries its own resonance. When your vibration is one of fear or doubt, you experience a world that mirrors uncertainty. When your vibration is love and clarity, you experience synchronicity, the effortless alignment of events, people, and opportunities. This is not wishful thinking. It's resonance in action. It's quantum physics woven into human experience. And when you step back and see the larger picture, it all fits. The ancient understanding of vibration, the modern study of energy, the quantum realization of unity. Everything in existence is one infinite field, expressing itself through waves and patterns, through you, me, and the stars above. You are not separate from the field. You are the field vibrating in human form, aware of your own frequency. The next time you feel stillness, listen closely. Beneath your thoughts, beneath your breath, beneath the quiet hum of your being, there is a deeper sound, a vibration that has no beginning and no end. That is the quantum field, the song of the universe itself, singing through you. Everything is vibration. You are vibration. And the universe is listening. The hidden language of reality, how consciousness shapes the quantum world. Imagine for a moment that reality is not a solid, objective stage, but a kind of symphony, a song being written and rewritten by observation, by awareness, by consciousness itself. This hour, we journey deeper into one of the most daring frontiers of modern science and philosophy, the idea that consciousness doesn't just experience the universe, it helps create it. Let's begin at the foundation. Quantum mechanics, as strange as it seems, tells us that particles exist in probabilities until they are observed. Before measurement, an electron doesn't sit neatly in one place. It is a wave, a field of possibilities. But when consciousness observes it, the wave collapses. Reality, it seems, waits for awareness to give it form. This has puzzled scientists since the birth of quantum theory. The famous double-slit experiment remains one of the clearest demonstrations. When unobserved, particles pass through both slits like waves, creating an interference pattern. But when observed, even indirectly, the pattern changes. The act of measurement transforms potential into actuality. Could it be that the universe, at its most fundamental level, is aware? Or, perhaps more startling, that awareness is the very foundation of existence itself? Some physicists, like John Wheeler, proposed the participatory universe. In his view, observers are not passive witnesses to a pre-existing cosmos. Instead, observation brings the universe into being. Every act of measurement, every conscious moment, stitches together the cosmic fabric. You and I, and every thinking being across time and space, are participants in a grand act of creation. But if this is true, what does it mean for the boundaries of the self? Is consciousness contained within the skull, or does it extend holographically throughout reality? The holographic universe theory, supported by studies in quantum gravity, suggests that the three-dimensional world we experience might be a projection, a vast, dynamic illusion arising from information encoded on the universe's boundaries. And if the universe is holographic, then consciousness might be too. Our individual awareness could be like a fragment of a greater whole, reflecting the totality of existence, much like each shard of a hologram contains the entire image. This brings us to a profound thought. Perhaps consciousness is the language through which the universe speaks to itself. Every thought, emotion, and intention may ripple through the quantum field. Some researchers exploring quantum biology have begun to suspect that microtubules within neurons may play a role in bridging quantum phenomena and cognition, a concept advanced by Roger Penrose and Stuart Hameroff. These tiny structures might act as quantum resonators, linking the subatomic world to human experience. If that's true, then each moment of awareness may literally influence the physical world, not metaphorically, but measurably. It also reframes our understanding of time and destiny. If consciousness can shape quantum states, perhaps the flow of events is not rigidly predetermined. The future may not be fixed, it may be continuously shaped by awareness itself. In ancient traditions, this was hinted at in mystical language. The Vedas spoke of Brahman, the universal consciousness from which all arises. The Taoists described the way, a boundless intelligence that animates existence. Even in the West, philosophers like Spinoza and idealists like Berkeley speculated that the universe was mind-like, not merely material. Now, with quantum theory, modern science is circling back to what ancient wisdom already intuited, that consciousness is not an accident of matter, it may be the ground of being. Imagine the implications. If your consciousness is connected to the quantum fabric, then every thought, every choice is like a note in the universe's music. Your awareness participates in reality's unfolding. You are not separate from the cosmos. You are its expression, its co-creator. Perhaps that is why synchronicities happen, those moments where thought and reality mirror one another with eerie precision. Perhaps that is why intuition sometimes knows before logic does. These may not be coincidences, but evidence of the universe's hidden language, a quantum dialogue between mind and matter. And so as we close this hour, let's reflect on a simple, breathtaking idea. Consciousness is not in the universe. The universe is in consciousness. Everything we see, feel, and imagine arises from that mysterious awareness that gazes out from behind our eyes. The stars, the galaxies, the atoms, the waves of probability, they may all be expressions of the same singular field of knowing. You are not merely observing the cosmos. You are the cosmos, aware of itself. And perhaps in the silence between your thoughts, in the space between each breath, the universe is whispering back, reminding you that it has always known you because it is you. The hidden language of reality is not mathematics or physics alone. It is awareness. And that awareness is listening. The infinite mirror, you are the universe in the stillness between thoughts, in the quiet pulse behind your heartbeat, there exists a mirror vast, infinite, and eternal. It does not hang in space, nor does it reflect light. It reflects being itself. This is the infinite mirror. And when you gaze into it deeply enough, you begin to see not a reflection of who you are, but of what you are. For all along, the universe has been looking back through your eyes. From the first particles that emerged out of the quantum foam 13.8 billion years ago, to the birth of stars, galaxies, planets, and the spark of consciousness within living beings. All of it has been part of one single unfolding, one great act of awareness discovering itself. You are not a bystander to this process. You are the process itself, a node of awareness in the infinite network of existence. Every neuron firing in your brain echoes the same intelligence that formed the structure of the cosmos. Every thought, every emotion, every dream ripples through the same quantum field that binds galaxies together. The atoms in your body were once part of ancient stars. The water in your veins has cycled through oceans and clouds, through generations of life, through ages of the earth. The light that reaches your eyes tonight may have traveled millions of years, and yet it now completes its journey in you, as awareness, as recognition. And that is the infinite mirror, consciousness witnessing itself through infinite forms. Science calls it interconnectedness. Philosophy calls it unity. Spirituality calls it oneness. But at the heart of all language, the truth remains the same. There is only one reality, endlessly reflecting itself as everything that exists. When you breathe, the universe breathes with you. When you think, the quantum field dances. When you look up at the stars and wonder, that wonder itself is the universe awakening to its own majesty. You are not separate from the stars you gaze upon. You are those stars, condensed, conscious, and reflecting. In physics, the observer effect tells us that observation influences reality. In consciousness, that principle extends to its deepest meaning. You are the observer through which reality takes shape. The act of awareness gives form to existence. Without the observer, there is no observed, no color, no sound, no meaning. This realization brings a quiet reverence to everything. Every leaf, every drop of rain, every moment of love and loss, all of it becomes sacred. Because all of it is part of you and you are part of it. The great scientist Max Planck, father of quantum theory, once said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." Consciousness was not a byproduct of the universe. It was the foundation, the source code from which all reality is rendered. When you truly understand this, separation dissolves. Fear begins to fade. You realize that death is not an end, but a transformation, a reconfiguration of consciousness back into the field from which it arose. You were never born as consciousness, and you can never die as consciousness. You simply change forms, like water moving from vapor to cloud to rain, always existing, always part of the whole. That's the eternal lesson of the infinite mirror. Everything you perceive is yourself, refracted through different expressions. The tree, the river, the wind, the stars, all are you, experiencing yourself in different guises. And when you love another, what you're truly doing is recognizing yourself in another form. That is why compassion feels natural, why empathy feels true. Because at the deepest level, there is no other. There is only you reflected infinitely, learning, evolving, awakening. Soft ambient pulse rises, heartbeat rhythm blending with star-like tones. So as we close this long journey, from the mysteries of the brain to the vast quantum ocean of consciousness, remember this simple truth. You were never just in the universe. You have always been the universe, conscious of itself, dreaming itself into form moment by moment. When you look into the mirror, do not just see a human being. See galaxies spinning in your eyes. See the fabric of space shimmering in your breath. See the eternal intelligence of existence, awakened here now as you. The infinite mirror shows no boundaries. It shows only infinity, gazing at infinity. And in that stillness, listen closely. You'll hear it, the faint hum of creation, the whisper of the cosmos. It says, "You are the light that sees itself. You are the dreamer and the dream. You are the universe."